Hello everyone, my name is Daniel and I'm a programmer and an artist, and today I've updated my Geometry Nodes asset collection, which is available on my Gumroad page for free, with some new nodes. With these 8 nodes right here. Sort of the theme of this set is arrays and deformers, so you got the array one-dimensional is pretty similar, but hopefully with a few improvements to the regular array modifier in Blender, and then they get more advanced from there. So I thought what I'd do today is just go through the array one-dimensional node and show you how that one works, and then we can go from there. I guess before we do that, I'll just go through and tell you what the nodes are and what they do. The array one-dimensional node is basically the same as your array node, or not your array node, your array modifier, but hopefully with some improvements. And then the array two-dimensional it's sort of like adding 2 array modifiers where you had one on the X and one on the Y, but it has some additional benefits like being able to affect every other row independently, which makes it easy to make bricks and stuff. Then there's an array modifier that fits quads, so it'll make an array that will fit the quads of your mesh basically. And then there's a curve deform, which is sort of similar to using the curve deform modifier. It kind of works the opposite though. This is the curve object, and then you pick an object to deform on the curve. But it's improved because you can have multiple copies, and then you can do an array to length. You can stretch or not stretch. So that's pretty cool. There's a deform to match quads. So this is slightly different from the array fit quads. The array fit quads makes an array to fit inside of the quad, and the deform match quad twists and distorts the mesh to fit inside the quad. It works better if the mesh that you're instancing is pretty square or rectangular, but then there's deform match UVs. It lets you take a detailed mesh that would be hard to shape and shape it using simpler geometry like this, and it works by matching the UVs. So if I edit the UV coordinates, you can see it moves around on the target mesh depending on how the target mesh is unwrapped on that UV space. Then there's a collection instance node, which is just a useful helper node to have. It basically just takes in a collection and turns it into an object. So that's great if you want to have like your base of your column here as 2 meshes, because this one has sort of a radial array and this one is different. But you want these to be one piece, well then you can use the collection to object to sort of merge them together, and now they're one object. The deform match curves plus caps is like the deform match curve modifier, but it lets you pick 2 additional objects, or give it a collection of 3 objects, where the first object's the base, the second object's the middle, and then the third object's the top. And that's like using the capped array modifier, sort of. And then it has some options to array the center and stretch. You can twist and you can make copies, all of that. The curve extend, if we turn this off, in its simplest form, you choose if you wanted to extend the beginning of the curve or the end of the curve, and then you choose a distance, how far. So you can extend the start, you can extend the end, you can extend both. And then you can also raycast against a collection or an object. And if you turn that on, then it will extend the curves along their last tangent direction until it hits something, if it hits something. So those are the 8 new nodes that I've added. Let's take a look at the array one-dimensional. First, just to go through all the settings, you can choose how many items are in the array, obviously. And then you can choose if you want a relative or a constant offset. And then one thing that you can do with the normal array modifier, but you have to use the object offset type, the object offset, is that it does rotation, and so you can rotate each element by an additional 90 degrees or whatever. So that's how you can get this one going horizontal, this one vertical, horizontal, vertical, etc. Then there's an option, The modifier creates them as instances first. You can keep them as instances, or if you uncheck this, it'll turn this into one mesh. And then if you do turn it into one mesh, you can merge the vertices to remove the duplicates, basically. And then you can also adjust the UVs, which is what this one's for. So you can see this plane's arrayed multiple times, but you can see where the seams are. If you turn adjust UVs on, it should automatically make it seamless on the UVs as well. And then you can choose, so if you use the normal array modifier, you can make it seamless, but it's like an arbitrary number that you have to find on this UV slider. So the way this one works is 1 will be, it will figure out the size of the face in UV coordinates. So this is, say, 1/3 of the UV space, and and then 1 on the UV offset will equal that amount, sort of like the relative offset on the array. Rather than with the normal array modifier, I think 1 is the whole width of the UV space. And then there's just an option for the UVs if you want to keep the rotation or not. All right, so the way this works is we're first going to come in with our geometry here, and we're going to build a bounding box around it. Then we're going to take the maximum of that bounding box and subtract the minimum from it so that we get a vector that represents the dimensions of the bounding box. And then we're going to multiply that by our XYZ offset so that we have a vector that represents the distance each subsequent element should be offset from the previous one. So that's this value is for the relative offset, and then the offset can just go straight into the switch for the constant offset. So that's what this switch does. Then, back to our input geometry, we're going to turn that geometry into an instance using the geometry to instance node, and then we're going to duplicate instances with an amount equal to our count that we chose. And then we're going to take the duplicate index, and we're going to take the duplicate index and we're going to scale it by our offset vector. Whether it's relative or constant, whatever we choose, we'll get the output from the switch, and we're going to scale that vector by the index of the duplicate. So the first one will be at 0, 0 because the vector times 0 is 0, and then the next one will be 1 offset, 2 offset, etc. So then we're ready to apply that with the set position. Before we set the position, we're going to go ahead and rotate the instances by our rotate vector. So to do that, we just take our rotation. We're going to scale that by the index. This should just be the duplicate index. Anyway, same difference, I guess. But yeah, we're going to take the rotation and we're going to scale it by the duplicate index, which again, the first index will be 0. So the vector times 0 is 0. The second one will be 1, 2, etc. Then we're going to rotate our instances by the rotation. Then we're going to set the position to our position scaled by the duplicate index, which gets us this. So then we're going to check whether we wanted to have instances or actual geometry. We're going to realize the instances if we have as instances false, and we're just going to take our set position otherwise. Then we're done if you don't care about UVs. That has all the functionality for building the mesh. The rest of this is just for calculating the UVs. And the first thing we want to do is capture the duplicate index from our duplicate elements node on the face corners so that we can multiply our UVs by them and stuff. So that's like that. Oh yes, and we want to do that, and we have to do that here because after we optionally, so the other option is do you want to merge by verts or not? If you do merge by vertices, then you can't read the index off the vertex anymore because some of those vertexes would have been combined. So we want to make sure we have our duplicate index saved on the face corners, which stay the same even after the vertices have been merged. So once we have that, so we either merge or don't merge depending on the switch. Then we have that output. Then we have a bunch of inputs to do with the UVs. We're going to scale our rotation value by the duplicate index again. That's exactly the same as the rotation we calculated over here, but this time we're going to send it into the UV adjuster. This is just in a group because I do the same basic thing on the 2D one. So what we're going to do in this group is we're going to take our array element, which is the original geometry before we copied it a bunch of times, and we're going to run that into a set position node, and we're going to set the position to the UV. So the named attribute with the UV name is a vector, and we're going to set the position to that, which looks like this. So this is the UV coordinates of this mesh. Then we're going to calculate the size of it exactly the same as we did at the beginning for calculating the size of the relative offsets. We're just going to do a bounding box and subtract the minimum from the maximum to get a size. Then for the rotations, I wanted to try to rotate it in a similar way that the mesh was rotated. So then if there is a rotation offset and we want to try to rotate our UVs to match, if we want to do that, we want to rotate around the center. Honestly, this is kind of impossible to make work for everything because the UVs are always going to be different from the mesh. In this case, they're actually the same because it's a square mesh and the square UVs. So anyway, I just thought I'd figure the center of the bounding box. So we take half of the size and add that to the minimum, and we plug that into the center of our vector rotate. Then we're going to take our UVs. That's the vector we're going to rotate. And then the rotation is going to be the rotation input we plugged into this group, which again was scaled by the duplicate index. I think it wouldn't hurt to put a multiply in here and multiply that rotation vector by 0, 0, 1, because we really only want to rotate around the z-axis. If you rotate it around the x or y-axis, you just be like squishing your UVs. So that's optional. Then we're going to take our rotated vector and plug that into a switch. And that switch is going to be the keep rotation setting. Then we're going to take our index from the index x and index y. There's two because of the two-dimensional array. But in this case, they're both the same value. So we just combine those together. So then we're going to take that index vector, and we're going to use it to multiply our UV offset by that. So this position value is the UV offset vector from the input. And we're going to multiply the size of our UV bounding box by that. You can see here we calculate the size, multiply the size by the offset. So that's the value you change here in the modifier panel. So then we're going to take the UV offset scaled by the size of our UV islands and multiply that by the index so that each additional element gets offset more than the previous one. And then we're going to add that value to the rotated UV coordinates, whether we kept the rotation or not. And then that's our adjusted UVs. And then we pass out the element size here just because we need that in the two-dimensional array. Then finally, we store a named attribute, 2D vector on the face corners with the name of our UVs, which we pass in here. And then we put that into a switch. The switch is whether or not we want to adjust the UVs or not. If it's true, we do the one with the stored UV attribute. And if it's false, we skip over all of that. And that gives us adjusted UVs. All right, so that's it for the one-dimensional array modifier. Not too difficult. Honestly, it's a pretty good one to make because it's easy to understand what it should do and to tell if it's working correctly or not. And it's a good way to practice duplicating elements and working on arrays of items and stuff in geometry nodes. I've just updated my geometry node assets collection. It's on Gumroad for free, or if you want to give me something for it, I always appreciate that as well. I've added these 8 nodes, and then I have... So here's the thing. Why doesn't all show the user library? Just a question. I have all of these nodes are the ones that are in there right now. So feel free to check them out, use them. Let me know what you do with them. I'd be curious. Anyway, that's it for now. Hopefully you found it interesting. Thanks for watching.